All right, let's begin. I'm sharing my screen. Welcome all. Welcome to kymeraTek Solutions. So this session is all about what this course is offering people, like who is going to start their career in DevOps or who is willing to upskill uh, from other domains to the current DevOps domain, and how this is going to help you to land in a job where uh, people can actually try for MNCs, product based, or if people are already working in MNCs, they can switch to product based with just 3 months of your time. So I would expect people who are uh, trying to register for uh, premium membership, like they would need to give 3 months of time, and I can guarantee you that you will get a job in a good product based company by yourself. So that is what this course is demanded for, and money anyone can spend. Time is something that people has to invest in themselves for upskilling or career growth. So coming to the topics, so this course is designed to like in such a way that with all my experience with DevOps, previous company experiences, interview experiences. So I have been a panelist. I've been a uh, uh, guy who has given so many interviews. I know in and out of what interview is expecting based on the job description. So that is what I am trained for, or have been training from past few years, and that is how I have designed my course. So how it would start is like very basic. People who has zero knowledge on DevOps can go through this, and then you will get to know what exactly like happens to you after 3 months. That is what the changes that you can observe it. But all I need is every day 2 hours of your time, 1 hour for session, 1 hour for practice, for continuously for 3 months, and then you can see yourself where you end up. So that is how I'm planning this. So coming to the topics, so here in this particular course, what I have kept is like pretty very basic. So to understand on a high level, I'm covering three pipelines. Okay, so one is CI/CD pipeline, which involves build and release, where we build the code, create the release. Second one is infrastructure pipeline, where we actually create the pipelines, like where it is going to provision environments, development environment, staging environment, and production environment, where you actually deploy your application, or where you can actually start your exposing your services, like any jar file, war file, or any microservice based architecture. So that is how you can actually plan. Third thing is deployment pipeline. So deployment pipeline is, yes, this is recording. If not, I have done this couple of times. I can share it. No worries. Okay. So coming to the third pipeline, it is development pipeline. Sorry, deployment pipeline, where we actually deploy our application using another tools. Like if it is EC2 based deployment, we go for Ansible. If it is Kubernetes deployment, we can go for Helm chart or Argo CD. So this pretty much that's it. So three pipelines: build pipeline, build and CI/CD pipeline, or build and release pipeline. Second one is infrastructure pipeline. Third one is deployment pipeline. If you go to any company, trust me, nothing more than this will be there on DevOps side. Combination of tools might be different, but if you see on a high level, these are the things that actually you work on. So there are a couple of automation, there could be couple of automations, there could be couple of process related stuff. So that is all company specific, you have to go there and learn, but these three things are common. Okay, there is no change in that. So to cover these three pipelines, we have couple of tools where I have already kept showed in the banner that I have told. So I'm going to discuss more about that particular three topics where we are covering. Okay, so to start with, how do I start? So I'll start with understanding of what DevOps is, how it has started, and previous to DevOps, what was the advantages and disadvantages of using normal traditional things that were going on, and how DevOps has elevated those things into next level, and how it has been helping developers to work on different things where their focus could be more on developing the code, and the rest all the things should be taken care by we DevOps engineers. Okay, so that is where our work is. So to be precise, our clients are developers. Okay, so maybe sometimes if you are working for testing team to set up the DevOps test pipelines, then your clients would be the testing team. So directly we don't yeah, sometimes we can talk to vendors or clients where who is using our application. If your application is being used by another company, we are responsible for them to integrate or to expose, or if there is any issues, yes, we will share our things, and then we will work with them. That is 30% of the work will be like that, but 70% our clients are developers, testers, and within our company project related people. Okay, so that's our clients. So I'll be talking about that, and then there are a couple of DevOps principles and practices which is nothing to do with your interview, but to understand what exactly you are doing throughout the course. After that, where you land up, you need those principles, you need those practices, and then so that is why we will cover that. And then culture and mindset is what you have to put in to any project, like DevOps culture, automate everything, reduce manual work, cost optimization. This kind of mindset should be there to everyone who is in that particular area, DevOps area. So people expect us to have that mindset and provide our ideas for them to actually reduce the tasks, timings, and releases, precise releases with very less failure rate. So like that. So that is the mindset that people expect from us. Third thing is uh, the life cycle, DevOps life cycle stages, and then you need to understand what kind of advantages do we bring for a project when you have set of DevOps team in a project. So what are the advantages before and after DevOps team implementation of DevOps? So I don't see any company or any project till now that there is no DevOps in their team. Every company has its own DevOps team, every project has its own DevOps team, and uh, very less chances that you get where you start from the scratch. Okay, if you go for startups where it is still in very seed provision, seeding stage, then you might see the very scratch DevOps team starting from very scratch. But otherwise, every company is already matured enough to use all the DevOps tools. It is just that you have to join the team and just understand what is there in that and how you can improve it and how you can continue with the existing setup. Okay, so that's pretty much if you go to any big companies or any MNCs, that is what people expect you to do, nothing more. And not from Elon Musk things, starting from new things, or like nothing like that. It is very pretty straightforward. You have to do whatever it is there, you have to continue to do, and you have to improve the existing setup. So that's how you can bring up the ladder from your current role to upper roles. Okay, so that's about basic stuff. Maybe one session I'll cover I'll cover this. Then we have agile methodologies. I'll take good amount of 2 sessions where I will explain about agile methodologies. In agile methodologies, you have two things: one is Scrum and Kanban. So we can go for both of those, Scrum and Kanban, and see how DevOps have used Scrum and Kanban to manage our DevOps team, right? So Scrum is more of development related tasks, and Kanban is more of support based orientation. So in my experience, in my past companies, I've used both Scrum and Kanban. So Scrum is for internal automations, roadmap items, roadmap tasks, or tools upgrades, or new tool implementations. So that's all pretty much DevOps improvement areas. So we apply Scrum there, and Kanban is for developers and testing team, where they raise the build issues. Then you get deployment related stuff, deployment related tickets, and if there is any failures in the environment, or if they need anything enhancements in the environment, then it will come as a Kanban support. Okay, so I'll talk more about that. I'll show you the boards, Jira board, how it will look like, the major changes between Scrum and Kanban, and then we'll discuss about that. Okay, so these are all pretty much management tasks which you cannot neglect, because if you join project, if you cannot speak the terminology, then you're easily caught. So uh, if you keep aside of getting caught or getting not caught, it is something that you have to learn, you have to understand. So then only you can. If you don't understand what you are doing, then there is no point. So to see how things are going, to understand what setup is there, you have to understand the basic stuff. So this pretty much covers 3 sessions, and I'll be giving all those inputs, and the terminology, epic, user story, task, bug, all those stuff, and then Jira tickets, Kanban, Scrum. So in interviews, how it would help is like, managers won't be having pretty much a clear understanding of technical CI/CD stuff, because they are much grown up and make sure that they are managing the project. So they are more interested towards this, your understanding of DevOps, your understanding of agile methodologies, how your current existing project setup is done. So they will be more asking questions there. If you can cover these two, then you would have more understanding of what agile and Scrum does. Okay, so coming to the technical stuff, this is where your technical thing starts. So throughout our sessions, we are focusing on Linux based systems. So I'll take Red Hat RHEL, 8 or 9 versions. So throughout our sessions, we are targeting only one operating system, which is more than enough. So every tool that we go, every environment that we create, everything that we run is completely Red Hat. So you'll be seeing that. So to understand that, to troubleshoot, to um, manage your day-to-day activities, so the first thing that you do is you log in into your laptop and connect to your Linux machine, and then start your work. That's how much Linux is being used on your daily basis. 70 to 80% of everyday tasks is done on Linux machines. If your project is .NET project, then it's a different story. It would be more of Windows and Azure DevOps and Azure infrastructure pretty much, because .NET is more of Windows oriented. So that's a different story. But anything apart from that will be always Linux or Ubuntu. So any one should be fine. So I am targeting Linux, Red Hat. So I'll be giving all those questions, troubleshooting sessions, and interview questions, like how I have planned for my previous batches. Um so we'll be having something like this, course introduction. You'll be having around these many videos, and I'll be sharing up all the documentation, so end to end, with all, and then interview questions as well. So you'll pretty much see all the interview questions with the answers during the sessions itself. Okay, whenever I tell each topic, so it is pretty much covered all the questions. Don't feel that these are too many questions, but if you divide and conquer, like if you do divide and conquer basis, like I'll take each topic, I'll complete the topic. During the completion of the topic, I'll give questions and answers. So I'll consolidate and give it in the documentation, where you can actually understand easily. Okay, so that's pretty much Linux, which is our operating system. Then we have GitHub. So it is source code management tool, so where we store our code, code base is our code base would be GitHub. So be it application code, be it our DevOps related automations, shared libraries, Terraform, Ansible, everything comes down to GitHub. So we are taking that as a source code management tool, and we are going to see the setup, authentication, authorization, and then branching strategies, basic questions, basic topics like git stash, squash, revert, reset, all those stuff with the live demos, not with the hypothetical theoretical things. It is all proper lab sessions. You will be seeing that, and I am going to give branching strategies separately where you can understand that. So um, you have to tell that in interview as well. So branching strategies is something that is a very much important question in GitHub. Okay, so I'll give a separate branching strategy. It is not that you have to tell exactly same thing, but every company doesn't follow the same thing. They have their own branching strategies, but the one that I'm saying is pretty much standard, that I've used in my previous organizations. So which is very much standard. I can relate that to my current company, previous, and any other project that I see. It is pretty much similar, so I designed that. Then we have a build tool. The code that we are taking is Java code, so I'll be pretty much taking that, and we are going to go for Maven. So Maven build is something that I'm focusing. So we will build the code. So there are two types of releases. One is manual release, the other one is using release plugin. We can release the builds. So we are going to do that, and our build tool is Maven. Then we have SonarQube. SonarQube is more of the code quality test, static code analysis, where it is going to go through each line of your code and then of application code. Okay, so it is more of checking the application code, understanding if there is any duplications, vulnerabilities, code coverage, unit test coverage, all those things are covered. Just make sure that the code is actually at standard best practices. Okay, so we are going to see that, and we are going to integrate it with Maven and Jenkins, so that we are going to see if build is passing based on the code quality. If code quality is not good, then we are going to fail the build. So we are going to set up that way. And then it is Nexus. Nexus is an artifactory tool where we store so Nexus has two things. Sonar type Nexus we call it as. So Nexus has two things. One is managing the dependencies. Okay, so we manage dependencies using Nexus with Maven. So whenever you build code with Maven, Java code with Maven, so Maven directly downloads everything from the internet, which in a company or environment it should not be done. It is not directly done from the internet. You cannot expose your application code or your build to the internet. So it is always done through proxy kind of tool, where Nexus here in this case Nexus behaves as an dependency management tool as well as artifact storage. So main purpose is to store artifacts. The one that you build, you will get an output like jar, var, or ER file. So we store that files for backups or for other teams to use it as an input and keep it under Nexus. First thing. The other advantage of using Nexus is it becomes as a dependency management tool, where you can actually store your dependencies and call them during Maven build. So whenever you do build, instead of going to internet and download the dependency, it is going to download from Artifactory, this Nexus. Okay, so I'm going to show you that setup and show the downloading stuff and all. Okay, that's about artifact management. And the master of all tools is Jenkins. So we the tools that above and below that I'm showing, so every tool is integrated with Jenkins. Okay, so Jenkins, the pipelines that I've been talking about have been created here only. Okay, we will create all those CI/CD pipelines here, and infrastructure pipeline, deployment pipeline, automations, any manual task that you are doing, all those stuff you can actually automate and trigger it through Jenkins. Okay, Jenkins is a CI/CD tool. So we will see the installation, setup, Jenkins file writing, shared libraries, And the advantage that my demo or my course gives is based on the branching strategies that I have said here. So the branching strategies that I have said in the source code management, I will use the same setup. I have written automations for that based on the branching strategy. So it is all written in Groovy pipeline, Groovy scripts, which we call it as shared libraries. And whenever you hit a build button, or whenever you commit your code to GitHub, based on the branches, my automation will see which kind of branch it is. Based on the branches, it is going to build, create an artifact, it is going to publish. If it is dev branch, it is going to publish snapshot artifact. If it is release branch, it is going to publish release artifact. If it is any other branches beyond dev and release branches, it will not publish anything. It will just build and give the code, give the output to you. Okay, so that kind of things I have set up. You can actually see that. Okay, so that's the first project. Okay, my first project covers pretty much the CI/CD, complete CI/CD using workflows, shared libraries based on the branching strategies. Okay, so that would cover CI/CD. Till here CI/CD is covered. So creating the artifact, that would be the CI/CD releases. So recently people are buzzing around Docker. So we have one more stage in Jenkins where we create application Docker image. Okay, till here we create the var file of the var or jar file of your application. But here in the Docker stage, we'll be integrating Jenkins with Docker, where you actually uh, see what exactly happens. I mean, the last stage would be Docker, where you create Docker application image, publish it into any Docker Hub repository or AWS ECR. So to deploy your application. So since if you are using microservice based architecture, or your application is already moved to microservices, you will be expecting this particular stage at the end, where your application image is being created, pushed into one of the repository. Okay, image repository. So that is where Docker is important. And to understand Kubernetes, we will cover Docker basics, including the networks, how to manage the storage, how you push the images, and Docker Compose is an additional advantage. Okay, so I'm going to cover all these things under Docker. Writing Docker file, understanding the Docker file, each of the directives inside the Docker file, what do you expect in interview, how to reduce the size of the images, which is an again interview question. So we are going to cover that particular topic. Okay, so now this is where our infrastructure, with this our entire CI/CD including containerization of application is completed. Okay, containerization using Docker. Your application, your 2-tier or 3-tier architecture or application can be done through microservice based architecture, where you can create front end one service, back end one service, and database as another service, and you can deploy it. Okay, we are going to cover that one as well. I will give a pass which has covered CI/CD so far. If you have any questions, if you have any doubts, do let me know before I go for next round of infrastructure pipeline. Any questions related to demos, course, or how things will be provided, let me know. I am happy to answer. Right, I'll take that as a no, and I'll proceed with next topic. Is this course okay for people who have no previous IT knowledge? Yeah, I mean freshers won't be having uh, the knowledge of what exactly DevOps is, or maybe nothing. See, I would say like anyone who has zero knowledge on IT can actually start, because right from very basic things, even though there are people who know or who has been working in IT and know some things, might feel bored, but still there are some things that people doesn't know on the interview perspective. So I would be starting from very basic understanding of why DevOps is included, even before starting the core topics. So it is helpful if you are willing to settle on DevOps, and I would encourage people to try it out, at least see if you can fit, at least by attending 3 or 4 demos. Maybe those are free demos. So you will get an understanding, and then you can decide whether this is your cup of tea or not. Why is DevOps important? mm, why DevOps is important? Okay, so that pretty much needs some good amount of time to tell why DevOps is important, but I will tell it in very few points. Uh, in general, let's say with DevOps and without DevOps. So let's talk about without DevOps. Let's assume that we are 10 years back, where DevOps was very at early stages, or DevOps was not there at that point of time. So developers used to write the code. So there will be product manager used to collect the requirements from the client, and then he will give it to the architects, the developer architect or development architects. So they will design the uh, high level and low level designs of the application, and then they will give bits and pieces to the developer lead assign those tasks to the developers. Okay, so now developers, what they do is they know how to write the code. Okay, so they will start writing on their laptops. They will build it on their own laptop, and every developer has their own laptops or desktops, and they will be writing their code, and it will work very perfectly fine on their code, on their environment, on their laptop. So like that, there will be, let's assume there are 10 developers. So each developer has written some code, and together all the pieces of code combined together, we get an application. So when they say that it is working fine on their laptop, when you club all the code, it is not working, it is breaking things. Now whose responsibility is uh, to check that particular issue? Like every developer says it is working on my laptop, it is your problem. Everyone talks like that, and developer lead is the one who is in charge of all 10 people, and he has to identify the problem, bottleneck, why it is been. So if you have a common environment to test it, then there won't be such issues. So developer write the code, he will test in his local, and then he will deploy it on the dev environment, and then he will test it with the other people code as well. So if it breaks, then it is his problem. If it doesn't break, then it's well and good. So he will give it to the other, his code to the other developers add their code, and then they'll start building it. Now to create such one second to create such environment specific um, things, like dev environment, staging environment, production environment, it is not developers who used to do that. It used to be done by operation team. So operation team produces this provisions these machines, like Linux, I mean environment specific machines, and they used to club, but they don't have any idea of how what needs to be there on the development environment, like what all the dependencies, what all the prerequisites to deploy the application and all. So again, there should be a middleware people who used to do that. So there were operations team who provisions the infrastructure, there is middleware team who manages those things, deploying the application or managing the application from the developers. So there were three different teams breaking their head to deploy one single application. So that's where DevOps came into picture by reducing these two teams. And if you see, like 10 years back, there are a lot of middleware teams. Even now, there are few, but not completely. Those have been replaced with DevOps team. Where I am just talking about one particular thing, about environment specific things, but there are a lot of things where there is lag, there is lack of communication, or there is lack of blame game happens between this development team, operations team, middleware team, at the end resulting in the delay of the process, entire deployment is delayed. So to reduce those bottlenecks, so DevOps came into picture by understanding the process, existing process. We will, we as a DevOps team, provide the easiest way, provide branching strategies, provide a deployment strategy, uh, give suggestions to the improvement areas of the existing pipelines, automations, which will help to ease the release at the end of the day. So develop, now we are decentralizing each and everything, okay, which means developer will write the code and that is his job. And we as a DevOps team, we are responsible for taking the entire code, creating an application and deploying it into the environment. Now tester comes into picture. He will test the code on the development or staging environment, and he will give approval, and then it is again our responsibility to deploy it into the production. So we are cutting the release team, sorry, we are cutting the middleware team, we are cutting the operations team, we are managing entire things. So we DevOps team, we manage, we write the automations, we change the model of deploying application or releasing the application by putting some uh, like like some kind of rules, some kind of strategy where it is going to ease the developer work. So that's how DevOps team has been helping the entire project to reduce the delay, to reduce the time of releasing things. So that's pretty much on high level I have covered, but in next sessions, in upcoming sessions, I will talk more about another areas, another dry areas where we can concentrate on automations, and how we help people to entire projects, like with our strategies. So that's where DevOps team is mandatory. Like earlier it was like middleware is there, operations is there, now DevOps is coming into picture. Why do we need these many teams? So once DevOps comes into picture, middleware and operations will go off and we take care of all those things. Okay, so DevOps engineer is bit versatile compared to operations and middleware, where he has capability to write automations in Python or Bash scripting, write couple of development related stuff, and manage the pipelines, understand the current process, provide improvements, then write the automations to those improvement areas, reduce the manual work. If there is something manually that we are doing everyday basis, we take those things, we automate it. So we write automations in Python, Bash scripting and stuff. Okay, so these are few areas that I can talk about, and still I can talk more, but it is not the time. So let's put our effort more on understanding the course, and then in next sessions it is covered, why DevOps. Okay, so coming to infrastructure pipeline, so the infrastructure pipeline includes cloud, where we provision infrastructure on AWS. So we are targeting AWS, since AWS is the market leader, or if you compare in the phones, it is like an Apple iPhone, where premium, it provides premium qualities, premium things. So it is not like other clouds are not providing, but since this has started its cloud base very much earlier than other clouds, so it has strong marketing teams, it has strong the infrastructure, um, though every cloud has its own disadvantages and advantages, but it is this is leading the market current at this point of time, and it's bit costlier as well. If I want to say as a disadvantage, AWS is bit costlier as well. So but we are because I know AWS, so I'm talking about AWS. So Azure is more of CI/CD thing. People are more if the project is more of .NET based projects, people are choosing Azure CI/CD pipeline and trying to deploy there only. Sometimes people use hybrid technology, hybrid cloud, where Azure can be used for CI/CD, AWS is used for infrastructure, and if people feel that AWS is costlier, they are moving it from AWS to GCP. GCP provides infrastructure at much cheaper prices than AWS. Okay, so but since AWS is market leader, and if anyone who has the experience, or anyone who is trying to work on DevOps, so they need to know one cloud, that should be more than enough. Okay, so there are some teams which doesn't need cloud. So right now in my team, we are not using any cloud. So there are some areas where you can actually uh, see on premises rather than cloud. But again, if you can learn cloud, you can actually apply those same terminology or same technical things to the on premises as well. Okay, in AWS we cover most of the infrastructure services, like authentication, authorization, and then networking, then computing, then we have storage, we have serverless services like Lambda, we have DNS routing, so we go for Route 53. So these are pretty much we cover, and we have databases, one database we can take. Okay, so we are covering these many things on a high level I'm talking about. So each, like let's say storage we have S3 buckets, EBS, EFS, so we'll cover all those things. Okay, so this infrastructure that I'm talking about, it is more of from the UI. Okay, so the when I'm talking about AWS, I'll cover most of the things from UI perspective, but in real time we don't do anything from UI. It has its own disadvantages. When multiple people are working on the same project and handling the same AWS account, then if you use UI, there will be lack of communication, where people try to override the other people's changes, which is going to mess everything up. So we go for Terraform, where Terraform is an infrastructure as a code. The services that we provision here, that is done through Terraform by writing the code. So don't worry, I am not a developer, I am not good at coding. So but still, if I can do it, you can also do it. It's not a rocket science. You will get every snippet from the internet. For interview you need to learn 5 to 10 lines, that's more than enough. But on a high level, Terraform has some standards, like directory structure, modules, data sources, dynamic blocks, the dependency creations, so backend state management, all those stuff. So we'll be talking more on that, and interview questions also will be on that, so that you will understand what exactly has been the current setup, and you can actually apply that to your organization standards. So that is also one good tool where people are using it extensively. Okay, so we'll cover multiple things here. And then we have Ansible. So you provision infrastructure, right? After provisioning infrastructure, so to deploy your application, you need to set up something. Like let's say your application is Java application, you need to set up Java versions, you need to set up certificates related to your application, and sometimes dependencies which are needed, particularly like JSON or jQueries, like that. Some kind of application related specifics needs to be added. So for those things to be done, we call it as configuration management. Okay, so before you deploy your application, you need to do some setup for your for your application, that we call it as configuration management. So that we do with Ansible. Also Ansible is used for deployment as well. Okay, we deploy our application using Ansible also. Okay, so I'm going to show both of those areas by showing the demos. We'll cover both of those. Okay, so then we have Kubernetes. So Kubernetes is where in continuation with Docker that I've talked about. So Kubernetes will be container orchestration tool where Docker can handle like 5 to 10 containers or 50 containers, 100 containers max. But if you are going for a microservice based architecture, Docker alone is not sufficient to manage those many containers. So that's where we go for uh, Kubernetes. Kubernetes is a container orchestration tool where we deploy our application and expose it from the Kubernetes clusters. So we go with starting with very basic understanding of Kubernetes architecture and deploying the creating the architecture and deploying few services. After that, I'm going to talk about AWS EKS setup where we can deploy applications, and EKS has one good advantage of choosing what kind of setup we need. So we are going to go in depth about that in Kubernetes. Okay, so we have Kubernetes resources, we have Kubernetes very basic things to the ingress load balancers, Istio service mesh and all. So we are not going to, we don't need those Istio service mesh and all. So we'll cover pretty much all the resources, all the objects, all the things inside Kubernetes. Okay, so when then we deploy our application and we expose it to the external world and see how it is accessible. Okay, we will cover ingress, service types, role based RBACs, we call it as role based access controls, how to manage the storage, PV and PVCs, and then network policies, networks, and then the pretty much basic stuff like deployments, replica sets, stateful sets, stateless applications, what that is and all in Kubernetes. Then we have Argo CD. Argo CD is pretty much the deployment tool on Kubernetes. So we go with Helm and Argo CD. Helm is a bit old tool where we use it for deploying applications by using Helm charts. We'll be having YAML files, a group of YAML files. We use that. We call it as Helm charts. We use that and we deploy our application. So I'll show that as well, and I'll show Argo CD as well, the main advantage and disadvantage of Argo CD. So Argo CD has advantages rather than disadvantages. So instead of managing complete Helm chart, you can actually Argo CD is a service which runs in the cluster as a service kind of thing, and whenever you update your version of Docker image here, like I said, at the end of the Jenkins CI/CD pipeline, we create Docker application image. If you change the version of that application image, automatically Argo CD will understand that, and it is going to deploy without your manual intervention. You don't need to set up the pipeline, you don't need to do any automation, you don't need to write anything. So all you have to do is initially set up Argo CD agent to monitor your application image version in GitHub. So it will be there in GitHub. You just have to feed that this is the application name and this is the version, and it is going to keep on polling. That means it is going to see if the change is there or not. If the change is there, it is going to pull automatically the latest image and deploy it. If the change is not there, it remains same. So that's the Argo CD, and it works based on the pull based mechanism. Okay, pull based mechanism. Then we have observability stack. So we need to monitor a lot of infrastructure. The infrastructure are two types. One is environment specific infrastructure. The other thing is tool related infrastructure. Means like we have to deploy, we have to install our tools, right? Nexus, Jenkins, SonarQube, and for Jenkins we'll have couple of nodes like to deploy our application, to run our tasks and all. So to manage those tools, we need infrastructure again. We need servers where we need to deploy our application, where we need to install these tools. So for that also we need monitoring. So one is environment monitoring, second one is the tools based monitoring, tools based infrastructure monitoring, and the third one is application monitoring. So we have three types of things. We call it as monitoring is an old terminology. You cannot, when you say that you are a DevOps engineer, so monitoring is not what you speak. You should speak about observability stack. Okay, observability stack. So under observability stack, we will go with Prometheus and Grafana, and we will see alert management and all in observability stack, and the real-time projects. Like I said, we are going to cover one CI/CD pipeline, how to containerize application. This is very simple. Static web hosting on S3 bucket. You can also do that. I'm going to show you during AWS sessions, and then we are going to deploy application on AWS EC2 infrastructure, which we call as 3-tier architecture using Ansible Galaxy roles. This is one complete project deployment. This is one deployment pipeline, and then we are going to set up DevSecOps using Terraform code, where we actually scan the code of Terraform as well, like how we have done scanning on SonarQube Java code using SonarQube. We will also go with one of the tool. Okay, so and one more thing was like why I kept it as DevSecOps is, so there are a couple of security things that we need to follow. One is code security, where we do the code quality checks using SonarQube. We can also have check marks or OZAP security tool, which is too much to ask to include. So one security tool on the code level is more than enough, which we go for SonarQube. So the artifact scanning tool also is there. Check marks, or we can go with OZAP security, but it's not needed at this point of time, and I don't think it is needed. But yeah, if you want me to show, I can show you. It's a simple setup. It will have one more stage to the Jenkins, and we can also do that. But I will show you Docker image security by using Trivy. Okay, Trivy, we call it as Trivy tool. So we use it for code quality, image security. Okay, vulnerabilities, container security, image security. So we can go for that. So I have done that in my previous batch. So I'm going to show you that. And Terraform also, we need to standardize our tasks, right? Like we need to see Terraform is written at its best practices level. So we will go with that as well. And then we have 3-tier architecture for AWS infrastructure by using Terraform. So I have written the code for that, and whenever you do a single click operation, based on the branches, if you commit your code to the branch, automatically this is going to trigger and provision infrastructure. If you want to update, you can update the file, and automatically your Jenkins job will pick the latest changes and deploy our Terraform infrastructure. So that is one project. And then deployment using Argo CD, that I'm going to talk. So with Argo CD itself, so at the end we will deploy using Argo CD. That is also one project where deployment pipeline will be included there. And then we will go through one like we will deploy our monitoring tools like Prometheus and Grafana, and the applications we deploy, right? So we are going to monitor those infrastructure by using observability stack, and set up the alert management. If something goes wrong, we'll get an alert to our Teams or Slack or like that. Okay, so everything that we do here will have Slack integration, where you get something like this. Okay, so failed jobs, successful jobs, and all. And at the end, I'll provide one couple of automations, bash script based automations, where I'm going to set up some disaster recoveries, some health check related stuff using bash scripting. And by using Python scripting, I have some scenarios which I have done in my experience. So I'm going to replicate the same, and I'm going to show you this code as well, share you the code. Okay, now we have interview questions for each of these. Like I said, each of the tool I will provide interview questions. Okay, so if you see, Linux has its own interview questions. Okay, so Git has its own interview questions, likewise Maven. So every tool has its own interview questions, and you can follow them, and I can guarantee you, if you go through those questions, if you go through the course, practice it, by end of the third month you can actually crack your own job. You don't need any support. So maybe one or two mock interviews to understand where are your improvement areas, where do you stand. So that would help you to brush up more on or concentrate more. But yeah, mock interviews are good. Instead of trying directly on the company level, I would always encourage people to take mock interviews, and then uh, they fetch you a proper interview which you can actually attend with confidence. Okay, so mock interviews can help you. And then frequently asked interview questions, like I said, I'm going to share you for all those tools that I've talked about. And then we have resume preparation. So I've already shared people resume building, like what we have done so far and what we are going to do. So which is pretty much good to understand. And so I'm not going to take or copy anything outside of our course. Okay, whatever we do in the course, I will write only those lines, and I'll keep those lines. If you practice it, if you get used to that, I'll keep, since we have kept only that, people will ask you questions on that and you can able to answer it. At least 70% you can answer it from the resume, and people expect you to answer from the resume itself, not the job requirement, but whatever you have kept on the resume, they will ask from that itself, or maybe tool wise, which I've already covered. Okay, so lastly, like I'll give some interview tips, how to predict next question from each interview. Understand how panelist is behaving, and see if he is already there are two types of panelists. One is the one who comes with the predefined questions. He doesn't care about your answer. If you are confident enough to say, he will go with next question that he has already written. So that kind of things happens mostly with MNCs. And if you go for product based companies, so they won't come up preparedly, so they will go with the flow. So whatever you answer it, they will cross question it. So you have to be very smart with these kind of interviews, where you have to tell in such a way that next question can come from your answer, your current answer. And you should give him lead that this, like, the answer in should be in such a way that uh, the the question will come from the same answer, and you know that question and you know the answer as well. So that kind of practice should be there, or maybe understanding should be there, so that you can easily crack those. See, all you have to understand is uh, how interviewer is behaving, whether he is coming with pre-planned questions, or if he is asking from whatever you say. So if he is coming with pre-planned questions, you don't need to worry. You can go with all the confidence, but learn and tell, so that you can be confident enough. But the one who doesn't come with predefined answers, that is where you have to uh, see like how people are behaving, and then you can answer it. Okay, so these are few interview tips. This is one tip that I follow, and then I would help you to understand like how to predict that at the end of the sessions. Okay, so that's what I'm offering right now with my course. And yeah, interview help will be there, with mock interviews and all. And people who need beyond that, we can discuss it offline, how to crack, how I can support you, all those stuff offline. But yeah, so that's about my entire course. And we can discuss more on next couple of sessions which are free, and I'll be updating the session timings and all in next couple of hours. Okay, I will stop here now, and I will let anyone speak if you want. If you have any questions, do let me know. So what happens is, I'm going to share my screen one more time. And we have an application called Drill Devops on the Play Store. Okay, so if you go to Play Store, I don't know if this opens me the Play Store. If you search with Drill Devops, you will get a tool. Okay, so this is the application that you can install by using your Android mobile. If it is iOS, we have class plus app. Okay, class plus app, class plus app store. So this is one app for iOS users, and there is my code, my application code where I can share. So I'll be giving those things from the WhatsApp group, and I'll be sharing that off through mail as well. The steps that you can do it. So next two sessions will be, one or two sessions will be from Google Meet, and from fourth session I can switch to the application so that you can start using it. uh, and everything will be through app. You can attend sessions from, you can also attend from this thing from the website as well. We have www.drilldevops.com. Okay, I don't know why it has been gone insecure, but yeah, so you can actually go here and see the courses. Okay, so this is the course that you need to register. This is completing course. Another 1 week this is going to get completed, and this is the course that I'm starting now. And you can pay from here, you can attend classes from here, you can get all the recorded sessions, all the documentation, everything from here. And you can pay with using card, with all the digital payments. You can make the payment, and once you make the payment you'll get registered to the premium content where I am starting from next week. And from there on, we can collaborate separately and see how it goes. Okay, so that's the starting point, and this is some basic stuff that I wanted to give today. And let me know if you have any questions from here on. Any questions, any doubts?
Bro, I'm having one doubt, bro.
Yeah.
In deployment part,
Yes.
in how many ways we can do deployment, bro? And second one is where we can deploy our application.
So one thing that I'm covering is, one is EC2 based deployment where you deploy it on virtual machine. uh, you can deploy it on EC2 machine on maybe Tomcat, or if you are if your web application is web application, you can go with Tomcat based or Nginx. You can deploy there. uh, uh, so by using Ansible. So that is what I'm covering on EC2 machine, by using Ansible, Terraform. Terraform for provisioning EC2, and Ansible for deploying our application, setting up the prerequisites, and then deploying the application. That is one deployment. The other deployment is on Kubernetes, where we use Helm charts and Argo CD to deploy our application on that. So there are two types of deployment that I'm covering. Deployment strategies are different: blue green deployment, canary deployment. uh, we have rolling upgrade. um, so like there are a couple of strategies that people follow. So I'm going to cover that during EKS, I mean Kubernetes sessions. um, these are two ways that I'm covering, and deployment strategies are separate, which I'm going to tell.
Okay, one more doubt, bro.
Yeah.
If we deploying our application in Kubernetes means
Mhm.
in this scenario that Nginx and Tomcat it will not come into picture, right? Correct me if I'm wrong.
uh, that is a question to discuss about how your application is designed. So in microservice based architecture, you can deploy your application. See, it is about building your image. So if you are building your Docker image with Tomcat application directly, Tomcat image, let's say you took one very base image, Ubuntu image. On top of that, you installed Tomcat, and on top of it, you have copied your application to the Tomcat folder. Then you use that image directly on the Kubernetes cluster to run as a pod, or run as a service, which means you are actually deploying your Tomcat application only with your application inside it. So that depends on how you have been architected it. So if you are deploying some backend services or front-end services, that differs. But if you are going with web application, like I said, you can create a Tomcat application with your application deployed in it, create an image out of it, and then deploy it on EKS, which is going to expose your service. So yeah, that's a different thing, but it depends completely on which what type of service you are deploying and how it is been architected, where it is being done. So you can actually deploy it on EKS, provide have an Nginx or one proxy server in front of it to actually mask your IP address of your pod or EC2 machine. So that's kind of that completely defines how your application is being designed. Any other questions anyone has?
Yeah, I have a question.
Yes, please.
Here, containerization, like, is container contained one application or service? Suppose we have multiple container applications, right?
Yes.
Each
So
con
so if you are deploying, see, that depends on if your application is microservice based architecture, each application, each microservice, see, application, if you see on a whole, application has different type of architectures. One is two tier architecture, three tier architecture, single tier architecture, entire architectures, and then microservice based architecture. So if you go with microservice based architecture, each container is a service, and if you have uh, like each application is one microservice, sorry, each container is one microservice. Now if you compare it with Kubernetes is operates in a different way. So you can have multiple pods serving only one single running only single pod. So it depends on replica sets that you have created, which is having a couple of same identical application. Like you are creating replica of your machine, your microservice, to serve your load. If you are having less load, you have single service, single pod. Like that you will be having 10 services with 10 pods, and if you are scaling up, then you will have 20 pods each. For each service you will have two pods for each service. So together all these services you call it as application. So service is bit different. Service has a different terminology in Kubernetes. You have service types: node, port, cluster IP, load balancer. So how you expose your microservice to the external load is what we call it as service in Kubernetes. But the way that you are asking is more of application specific, not service specific. So if you ask me like application, how many containers can run? So each container can run multiple applications running on different ports. Like you can expose different ports, but again that is not recommended. Each container can run one service with one port exposed. Again, if you run multiple services on the same container, what happens is your image, your container will become big, which is again pretty much very much equal to EC2 machine. Why do you want to go for again Docker when you want to run all the services in one single application? You can go for directly for EC2 machine. So that will be the question that is going to get asked in interview. Like why do you need, when your application when your all your microservices or all your applications are running one single container, why do you need Docker in between? It will become, obviously image will become bigger, containers will be loaded, where containers, where it will run again on the EC2 machine. You need a bigger EC2 machine. On top of it you want to install Docker, and then on top of it you are running Docker. Why do I need that headache? I will remove that Docker and I will directly deploy my application on EC2 machine, and I'll expose. Why do I go for containerization? Containerization is used to make our job easier, to decentralize everything, and then expose it, so that applications will not, even one service goes down, other services are there to have serve the load. That is one thing. The other one is Kubernetes has a lot of advantages: self-healing, self scaling, self many things we can do around custom resource definitions, CRDs we call it as. So that's a different story. We can talk more about that in future.
Oh, okay, bro. If we go with the AWS deployment, the AWS will taking care everything, right?
No. See, again, AWS has two types of deployment. One is EC2 based deployment, which we call it as instances. Okay, servers, plain servers. EC2 machines are plain servers, Linux machines. Again, EKS is not running on the air. It runs on again EC2 machine only. Backend there will be node group, managed node groups. We have couple of types, so those machines will be there. On top of that, we have Kubernetes plane. On top of that, we deploy our application. So at the end of the day, backend is the core thing is EC2 machine only. So it is all Linux machine, and on top of that you are running these applications.
Okay, got it.
Yeah. Any questions, any doubts? If you don't have any other questions, then we can wind off. I'll update you the next demo when and where, and let's see how it goes. Okay, so that's all from my side. If you don't have any questions, we can wind off, and I'm going to share you the course link, and I'm going to provide all the details that you want. And if you have any questions, or if you have any questions related to interview specific, or how it can be done, you can call me or you can ping me. I'll be available on my numbers and on the group as well. Maybe we can connect separately. Okay, that's all for today. Let's connect back, and hope I see few members there as well. Okay, thanks all. You
Yeah.
have a good
Thank
weekend.
you.